What is Faraday's law of induction and its meaning? Imagine you are holding a magnet near a coil of wire and suddenly moving it back and forth. You might not see anything happen, but something is definitely taking place inside the coil. This is where Faraday's law of induction comes into play. It explains how changing magnetic fields can produce electric currents. This law is a key part of the larger set of equations called Maxwell's equations, which describe how electric and magnetic fields interact. Faraday's law states that if the magnetic flux passing through a closed loop changes over time, it will induce an electromotive force, or EMF, in that loop. Magnetic flux is basically the total magnetic field passing through an area, like a coil of wire. When this flux varies, it causes a voltage to appear across the wire. If the circuit is complete, this voltage drives an electric current. This law has two main parts. First, when a conductor or coil is exposed to a changing magnetic field, an EMF is generated. If the conductor forms a closed circuit, this EMF causes a current to flow. Second, the size of the induced EMF depends on how quickly the magnetic flux changes. Faster changes mean higher voltages. Faraday's law is fundamental because it explains how many electrical devices work. For example, in a generator, mechanical motion moves a magnet near coils of wire, changing the magnetic flux and generating electricity. Transformers also relying on this principle by using changing magnetic fields to transfer energy from one circuit to another. Magnetic flux is calculated by multiplying the magnetic field strength by the area it passes through and the cosine of the angle between the magnetic field and the normal to the surface. If any of these factors change, like the magnetic field strength, the size of the coil, or its orientation, the induced EMF will change accordingly. Lenz's law complements Faraday's law by telling us that the induced current always opposes the change in magnetic flux that created it. This is a way of conserving energy and explains why the current flows in a direction that tries to cancel out the change. In essence, Faraday's law of induction shows us how changing magnetic fields can produce electric voltages and currents. It is the foundation for many electrical systems and devices that power our modern world.